Okay, that was pretty good. You actually can see that. This is the second chapter on gases. And it's going to have to do with Avogadro's principle. You've heard of Avogadro before. You heard that number, 6.02 times 10 to the 23rd. What is Avogadro's principle? Well, our principle is Mr. Krupp. But Avogadro had a principle too. Different kind of principle, right? Well, how is it different? The word.
There's no pal.
That's exactly. P-A-L, because the principle is your pal for the person. But this is the principle, like as in the rule. All right, what did Avagadro find? Well, he found, as somebody saw this last period, and said, oh, good, there's going to be a demo today, because I use this so you can see the demos in the back all the time. Actually, this is the demo today. That's right. Yeah, not a very exciting one. It's just a box. However, it has to do with what Avagadro figured out. Here's what he figured out. He said that the same volume of gases, no matter what the gas is, it's going to take up the same amount of volume. It's going to have the same number of particles in it, same number of molecules, or same number of atoms. Okay, equal volumes of gases at the same temperature and pressure contain the same number of particles. That's what he figured out, and that's a big deal for us because it allows us to do yet another conversion, yet another way we could do conversions that we've already learned how to do with moles and grams and atoms. We can now do with volume.
Wow.
I know. It's very exciting. The reason this box is the size that it is this happens to be, if you've ever looked here, you may have seen, 1 mole written on one of these sides. There's a lot of different things written on different sides. 1 mole written there. But on this side, it says 22.4 liters. And that is the volume of 1 mole of any gas. It could be 1 mole of hydrogen gas, all right? 1 mole of nitrogen, 1 mole of carbon dioxide. It makes no difference. Basically, 1 mole of gas at STP is always going to take up 22.4 liters. It's always that's going to be the volume. I have to qualify the at STP part, guys, because as you learned last chapter, if I don't tell you what the temperature and pressure is, that volume is going to change. It's not going to be 22.4. And that is going to be a problem for some of our calculations in this chapter. All right? Well, this next thing I'm going to show you here is going to show you where I'm going with all this. Last chapter talked a lot about volume, pressure, and temperature changes. We learned a lot about gases and how they change their volume, temperature, and pressure based on each other. For the previous 10 chapters before that, we worked our way up to stoichiometry. And in stoichiometry, we use many conversions, including moles to molecules or atoms to grams. What we're going to do now, this is our link. Avogadro's principle is our link between stoichiometry, all that we learned there, and all that we're going to learn, and we have learned in gases. Because 22.4 liters of any gas at STP takes up, or is 1 mole. 1 mole is 22.4 liters. They're the same thing. By the way, I didn't have room to fit this all across, but that should be 6.02 times 10 to the 23rd atoms or molecules. You could write that underneath there. Atoms or molecules. Okay. That's it. Now, that's all. I have 3 examples we're going to do on the board here, and that'll be it, basically. But I'll keep recording because, like I said, for those people who be able to leave early, I'll do 2 classes in one, then I could just post 1 video, hopefully. All right, but let's do 3 examples of this because they really are very easy. Watch. How many moles are in 44.8 liters of any gas at STP? This goes back to the first things we learned how to do, conversions. Kind of needed to know how to do conversions. If this question, let's go way, way back, the way, way back time machine. 44.8 liters, and I wanted to convert it to milliliters. You would do it the same first step and the same second step. What's the same first step you would have used? What would you do if you're converting liters just to milliliters? What would you have done?
Write the given information.
Exactly. I'm going to write down 44.8 liters. And the same second step. What units are going to go on the bottom because I have to cancel them?
Liters.
Right. And the same third step. What's going to go on top? What am I looking for? Well, I look at the question. What am I looking for?
Moles.
Moles. So basically, this procedure hasn't changed much. The only thing that's different is I now know a new conversion factor. I did know 1 mole contained that many atoms, contained the atomic mass in grams. Now I know it also contains 22.4 liters. What goes next to moles? 1. 1 mole contains 22.4 liters. That's why it works. Now, you don't need a calculator for this because I made it so darn easy. It's 2. But do I just write 2?
2.00.
2.00.
Yes, I'm learning.
Yes, she is. 2.00 moles. I'm learning.
Laughing.
Okay.
Loud.
LOL out loud. There you go.
Hi, Mom.
All right, let's get through a few more of these. Now, look, as you probably figured out, in the old days, we could have done multiple versions of this. Could have gone from moles to atoms, or moles to molecules, or moles to grams, grams to atoms, or grams to molecules, a whole bunch of different ways. Now, I've got one more way I'm going to do it. I'm only going to do 3 examples. There's a lot more than that, but let's do the next example. Copy this guy down. This time, I'm asking for the mass, and I'm giving you the volume. Okay, so by now we know. We don't automatically put liters in the bottom or liters in the top. I don't automatically put moles in the bottom and moles in the top. I follow the units. That's what I've always called it. And you can use this system to convert anything. I don't care if you're doing baking and you're converting cups to teaspoons or tablespoons or whatever. You can still use this system. You write down the given information. 11.2 liters. You write down the correct units. Liters go on the bottom in this case, and I'm asked for, in this case, it doesn't tell me specifically the unit, but I know the unit of mass is what? Grams, right. All right. Is there going to be a 1 somewhere this time? No, people often, even at this point, still think that. They think, well, one of them is going to be a 1. No, it's not. The only thing that has a 1 is moles. What's going to be next to liters?
22.4.
22.4, we just learned that one. And next to grams will be the atomic mass, but it is not 1.0079, which is exactly what I got in the last class, because hydrogen is diatomic. You still have to keep that in mind. There are 7 diatomic elements. Hydrogen is one of them. It'll be 2.0156. You have to multiply 1.079, 58, I'm sorry, 58 times 2. All right, now again, I don't even need a calculator for this one because this guy goes into here twice. I'm going to divide him in half, and I'm going to get 1.0, for significant figure's sake, 1.01, I believe. Is that right? Significant figures, I think? Yeah, for significant figure's sake, 1.01 grams. And that's your answer. All right, I do one more of these, and then I would have stopped, and you could have done your homework or your problems that you're going to want you to work on, and then next period I would have done the next one. But I'll do all of it at once, okay? So let's do one more example of this.
What a kind man.
Because I am. Don't tell anybody.
You're really softening up.
I know. I'm really a nice guy. If I had friends, you could ask them.
That's me too.
All right, what's the volume of 2.57 times 10 to the 24th molecules of CO2? Now, sometimes it matters what the gas is. Like up here, it mattered that it was hydrogen because I had to look up H2 multiplied by the atomic mass. It does not matter that it's CO2, and you'll see why in a minute. It doesn't make any difference. By the way, that confuses people. One of my questions I know in one of my works is going to say molecules of any gas. And people will go, how am I supposed to know what to put there? Follow the units, and you'll realize you never needed to know what the gas was. Watch. I write down 2.57 times 10 to the 24th molecules. And I begin my conversion. Molecules have to go on the bottom, of course, because they have to cancel. Volume. What's the units of volume? What are the units of volume? Liters. All right. Go on the top. Think back to my new conversion factor. 22.4 liters are in 1 mole. And how many molecules are in 1 mole?
6.023.
Exactly. It's a number that's stuck in your head already. Now, you get your calculators out and you multiply those, and that's what I want you all to do right now because, yet again, it's one of those things where we don't use them for a couple of weeks or a month or so, and you forget how. Plug it into the calculator. You plug this guy into the calculator like this, 2.57 exponent button. Not times 10 EE, but just the exponent button, 24. Right? And otherwise, you're going to get the wrong answer. You'll be off by a decimal. All right, do all that. Multiply by the numerator, divide by the 6.0 to 2 to the 10 to the 23rd. Jared, what'd you get?
I got 95.6.
Everybody else get 95.6? Look good to everybody? All right, good. Now that would be a cut, wrap, and print. But you would work on some problems out. But let's go on to the next thing, and I'll try to keep it all in one video here. Okay, you ready?
Is this one longer or shorter?
I don't know. I didn't do it today, so I don't know. All right, everybody good with that though? Got a copy? All right. Let's do the next one. Now, what you would have learned next period would have been about, oh, by the way, your homework's over there, 47 and 48 on page 355. I already, okay, density problems at STP. That's going to be our first lab. We're going to do, again, at least 2 labs in this chapter. Last chapter, I think, had 3 or 4. This chapter, I think, has 2.
What would you entitle this chapter?
No, I'm sorry. This one, maybe I have 3. No, 2 or 3. I'm not
Okay.
sure. Gases and the mole.
Okay.
All right. How do we solve density problems? That's how I would do that.
Gases and the mole.
Yeah. Okay. How do we solve density problems with gases at STP? All right. We can actually do this. It's kind of interesting. Watch when I give you a question like this. I want you to find, well, write that down. Remember 2. I want you to find a density. There's really no notes in this case. Just go right to the examples. Example 1. Find the density of nitrogen gas at STP. What does it appear that I've forgotten to give you? Everything! Normally, if I'm doing a density problem, what 2 things do I need? Mass and volume, right? Well, here I just told you to find the density of nitrogen gas at STP. I didn't tell you anything. Why? Why? What do you think? Well, I needed to, let's start them off. You guys help me out here. I know density is my unknown, correct? And I know I must have somewhere M and V. Can somebody tell me what the mass is going to be in this case? What do you think?
The atomic mass.
The molar mass or atomic mass of the compound I'm talking about. Don't write it down yet because I want to talk about that in a second. What will the volume be? 22.4. Look at all of this is possible because I'm going to, in all of these cases, assume 1 mole.
You know
Okay.
what happens when you assume?
You make an ass out of Emily Dalo. Right. Anyway, you make an ass out of, you know. It's not the you and me part you're not supposed to say. It's the other part. Anyway. All right, so what's my mass of nitrogen? I look up there, 14.007 times 2. He is another guy that is diatomic. So 28.014 grams. Volume? Was it what again? Volume of 1 mole of any gas at STP? 22.4. See, this is why I can do this. All right, because of these new things I just learned. All right, so D equals M over V. So D equals 28.014 grams over 22.4 liters. You need a calculator, get it out. What do you get? What did you get, Zach?
1.25
grams over liters. Grams per liter. Does that sound right to everybody? 1.25? All right. Now, can I ask it the question a different way? Yes. As a matter of fact, it's one of the ways. Actually, I have a lab, but I've never done it. Maybe this year I'll try it. I bought where you could actually find what can I leave as another variable? What am I going to have this as the variable? If I'm talking about 1 mole of a gas, will volume ever be the variable I'm solving for? If I'm at STP? No, it's always going to be 22.4. But I could have the molar mass. And actually is a way of determining the molar mass. I actually bought this a couple years ago, but I never really got a chance to use it. Of determining the molar mass using the density of a gas. All right, it's kind of neat. All right, so let's do that for this next example. Find the molar mass of a gas whose density is 2.5 grams per liter. So if I give you the density, you can figure out the molar mass. And you do it the same way we've done every other equation type problem. We write down the given information to the side. We pick it out of the problem. It's pretty funny. Even density has come back. Remember a little while ago we took the midterms and you were saying, like, well, is the final going to be comprehensive? And technically, no, it's not. I'm not going to ask you the very specific, annoying questions from early chapters. However, probably 80% of it's comprehensive anyway, because here we are in the second half of the year, and we're already seeing conversions again. We're already seeing density problems again. You know, it's not like that just got stuck back there. And you know what you're also going to see by the end of this chapter? Stoichiometry again. So, although I'm not going to ask you specific questions probably on, trying to think of something that was completely off the, like periodic table trends. I wouldn't ask something like that on the final. I will ask questions like this, which include density, which we learned way back in chapter 2. All right, so density is 2.5 grams per liter. The mass is my unknown, and my volume is 22.4 liters. I think everybody would know that, right? In your homework tonight, I have only half the homework up there. The other half I'm going to put up there for this one because I wasn't, expecting to do that. I will. You'll be doing problems like these. All right, D equals M over V. Slightly different this time. I got to solve for M. What am I going to do to both sides to solve for M? Multiply both sides by V. You see why? Because that's how you get VD. V cancels. All right. And you get M equals V times D. Or 22.4 liters times the 2.5 grams per liter. Notice you kept your units. If you kept your units, you notice right off the bat that liters cancel and leaves you with your answer. I wonder if blue looks good on this one. Let's see. Can you see? No, you can't really see blue, can you?
No.
Anyway, work that out so you get for your answer. Maybe I bet you can see orange. Let's see if you can see orange. Go ahead. What's your answer for that?
56 grams.
50. Yeah, you can see that. Grams. I can use orange.
That's a good color.
Yeah,
It goes out. It brings out your eyes.
Thank you.
What
My eyes are not orange and
about yellow?
Yellow would work, I bet you. Oh yeah. Oh yeah.
We're just getting fancy.
That's an L. You know my favorite letter is L. This is that's the prettiest letter. And you can just make it forever. You just make L's. Isn't that great? I love L's. That's a great letter. Okay, I don't think I have any more problems. I hope I don't. Let me see. Nope, that's it.